Assalamualaikum, kami daripada kumpulan 6 akan membentangkan SCL. Nama saya Siti HIDAYAH binti ABDUL KAILANI, nombor matrik 208125.
Nama saya KHAIRUL bin UDIN, nombor matrik 207435.
Nama saya NURUL NABILAH binti RIDZUWAN, nombor matrik saya 197-666.
Nama saya MUHAMAD SYAHIR bin SYAHMI dan nombor matrik saya 207322.
Saya Siti AISHAHKHADIJAH binti AHMAD dengan nombor matrik 207742.
Okay, baiklah kita teruskan kepada pembentangan soalan. Okay, baiklah untuk soalan pertama yang kami pilih adalah soalan nombor 2. Let fxy equals to exponent x square plus y square on region x square plus y square less or equal to 1. And double integral is as below. The question is write the double integral in rectangular coordinates. So for as we know, the region is x square plus y square less or equal to 1. So area of the circle which is equals to 1. And then we factorize, we get the radius also equals to 1 and the coordinate equals to 0, 0 for the middle coordinate. And we get the boundary of y equals to y equals which is x square plus y square equals to 1. We move and we get y equals to positive negative square root 1 minus x square. And for x boundary, after we substitute y equals to 0 into the equation, we get x equals to positive negative 1. So the double integral in rectangular coordinates is equals to integral with boundary of 1 and x equals to negative 1, y equals to positive square root 1 minus x square and negative square root 1 minus x square exponent to the power of x square plus y square dy dx. So for the second B question, I pass to KHAIRUL.
Now for the question B, they want to us to write the double integral in polar coordinate. So the first we do x, x equal to arc cos theta and y equal to arc sin theta. So we use the Jacobian. So we get that cos theta, negative arc sin theta, and arc cos theta. We solve that and we got arc. Then we take the x square plus y square equal to arc square cos square theta plus arc square sin square theta equal to arc square cos 2 theta plus sin square theta. Then we got arc square. So the double integral in polar coordinate for this is integration 2 pi theta equal to 0 to 2 pi and r equal to 0 to 1 er square r d theta.
So for number 2C, we have to show that the combinations of the double integral in the question B is pi square bracket e negative 1. So here we have to do the double integrations and we have to integrate respectively theta and also r. And by integrating the theta, we got theta, and also when we integrate r, we got 1 over 2 er square. So we put the value and we got pi square bracket e negative 1. Thank you.
Question 3. Using polar coordinates, find the volume of the region above the xy plane and below the graph of z equal to 1 minus x squared minus y squared. So the first step is we need to convert the graph of z equal to 1 minus x squared minus y squared, which is in the Cartesian coordinates, and we need to change this into polar coordinates. So to do this conversion, we need to remember the formula of r squared equal to x squared plus y squared. There are also another two formula which is conversion formula, which is r equal to x cos theta and also x equal to r cos theta and y equal to r sin theta. So in first step, we use r squared equal to x squared plus y squared. We replace from this z equal to 1 minus x squared minus y squared, and then we get z equal to 1 minus r squared. So the second step, we find the limit in polar coordinates for the region D. Z equal to 1 minus x squared minus y squared equal to 0. And then we transfer number 1 to the right side. We transfer the negative x squared and negative y squared to the right side, and we get x squared plus y squared equal to 1. And so from here we can see that the region D is a unit circle with radius 1, and we can describe the region as D equal to curly bracket r theta. R is between 0 and 1, and theta is between 0 up until 2 pi. So the third step, we set up an double integral to find the volume. So here is the formula, is 1 minus x squared minus y squared dA, and then we expand the formula and we get 1 minus r squared, which is we already convert in the first step, and then we just need to do a normal integration, which is we do the inner part, the integration of r minus r cube with respect to the dr, and the lower limit of integral of 0 and the upper limit of integral of 1. And then after we complete the first integration, we do the outside integration for the integration with respect to d theta, and then insert the value of integral, and we get final pi over 2. The final answer, pi over 2. Thus, the volume of the region above the xy plane and below the graph of z equal to 1 minus x squared minus y squared is pi over 2. I think that's all from me.
Lastly, we choose question number 4. So from the question, we are given region from x equals to 1 to x equals to 2. So x is varies between 1 and 2. Okay, y is varies from 0 to the function of x. So the region that we are after is in between these 3 lines. So the region is the shaded line. So inside the region, the smallest value of the Sarah is equals to 0. Then Sarah runs all the way up until it reaches the maximum, which is pi over 4. So we're going to have Sarah running from 0 to pi over 4. Okay, next, in order to get our ranges, we need to do some trigonometry. So from this triangle, we have the angle theta, and the adjacent is 1. There, the hypotenuse is r, which we are going to find. Okay, we know that cos theta is equals 1 over r. So r is equals 1 over cos theta. And another r is equals to 2 over cos theta, because instead of going over length 1, we go over length 2. So the integral become r equals to 1 over cos theta to 2 over cos theta. Now, we re-express the original function in terms of r and theta. So the original function there, x squared plus y squared, and we know that it's equals to r squared. And dy dx become r dr d theta. So we integrate 1 over r squared as usual, and we got this final answer, which is square root 2 over 4. And I think that's all from Group 6. Thank you.